Welcome back, students. Today we are going to discuss the concept of data sufficiency. Only data sufficiency question in previous year, what are all the questions they had asked, we are going to discuss how to solve those questions easily. Right, let's move to the concept. The first thing, the questions which is given using the variables. 3 of the 5 positive integers p, q, r, s, t are even and 2 of them are odd, not necessarily in order. Consider the following, they gave 2 statements here, right. My question is, when we know the basic concepts, the ideas already, we can get the answer quickly. So, in all the explanation, when we taking this question in the class from the basics, I had said even into even is what, odd into odd, even into odd. So, if I know all these things, I can get the answer quickly, but as a candidate, if I don't know anything and I got this question in my exam, at the spot what I should do. So, that is what we are going to discuss here. Generally we can use some basic concepts too, but when you do not know the concept, always use the concept of plugging in. Just take one numbers, example numbers, and plug here and get the answer, but you should do that 2 to 3 times fastly, right. You can get the answer. Look at this, totally 5 numbers are there, variables p, then q, r, s and t. Okay, I am going to take some combination of numbers for checking this. Let us take, they says that 3 are even number and 2 numbers are odd number. First take as it is, even number 2, 4, 6, odd number 3 and 5. This is one combination. Then I had take first number is odd number, then 2, then again odd number 5, then 4 and 6, right. Any other combination 3, 5, then 6, 4, 2. So, like this I can take some combinations and just check. Still you had a doubt, you can take another 3 more combinations, right. First, p plus q plus r minus s minus t is definitely even. Look at the word definitely. There are so many words they can use in your exam, we should concentrate on that. Definitely, must be. Okay, so these words says that whatever the number, whatever the combination I am going to check, I need to get only even. But same time if they use can be, right, any one number gives the even number, that is enough for us, right. So, but here they says definitely means for all the cases I need to get same answer, it should not change, I should definitely get even, right. Okay, first p, okay, so p is 2 plus q plus r, so 4 plus 6, then minus 3 minus 5, same order p, q, r, s, t, this is the symbols, right. What is the value? 4, 6 plus 6, 12 and 5 plus 3 is 8, here it is 4, even number, our answer is right. And take this 3 plus 2 plus 5 minus 4 minus 6, right. 5 plus 5 is 10, here 10, I got 0. Yeah, this is also we can consider as an even. Then 3 plus 5 plus 6 minus 4 minus 2, right. And 6 plus 5 is 11, 11 plus 3 is 14, 14 minus 6, 4, 4, 8, I got even number. So, as of now every numbers gives whatever the combination I take in different ways, it gives the even. So, the first statement is right. Check the second statement, 2 times p plus q plus 2r minus 2s plus t is definitely odd. Here the same concept, they are saying that it is an odd number. Okay, let me check with the same numbers. So, 2, right, 2 into p, first we are going to check with this combination, 2 plus q is 4 plus 2 into r. So, 2 into r is what? 6 then minus 2 into s is 3 plus t, that is 5. Look at this, whatever the operations are given here, we should use the Bode-Moss rule, right? Without that, don't do as it is. So first 2 into 2 is 4 plus 6 into 2 is 12 minus 3 into 2 is 6 plus 5. Now only plus and minus. Okay, so I can take 4 plus 4 is 8, 8 plus 12, 20, 20 plus 5, 25, I get 19, right? Okay, so here I got the odd number. Okay, let's take the next. Okay, next combination. Okay, 2 into p, that means 2 into p is 3, then plus q, q is 2, then plus 2 into r, r is what? 5, minus 2 into s is 4, then plus last one is 6, right? Now do this. Here I got 3 into 2 is 6, then 5 into 2 is 10, again 4 into 2 is 8. Okay, 6 plus 2 is 8, 8 minus 8 getting cancelled, so 10 plus 6 is 16. Look at this, guys, I can write it separately. Look at this, 6 plus 2 plus 10 minus 8 plus 6. 6 plus 2, 8 plus 10 minus 8 plus 6. I can cancel this. So final answer is 16 plus 10 plus 6, but here they says it should be an odd number, but I got even number, so this one is wrong. Is it clear? So let's check with some numbers using plugging in concept. You can get the answer quickly. If you know the concept, you can use it without writing the numbers. I know that odd plus odd is what, odd into odd is what, even into even is what. But if you don't know that, take some numbers and apply here, you can get the answer. Let's move to the next question. P and composite number C. So they gave two equations. Here the combinations is between prime number and composite number. Either I need to know the rules or else we are going to use the plugging in. I'm going to solve this question in the student perspective. Let use some numbers and check with the equations. First thing is prime number plus composite number over prime number minus composite number can be even. Look at this, guys, here they are using the word can be. Previous question they says it is definitely. Here can be means you no need to get answer for all the numbers. If any one numbers gives even, any one numbers gives odd, you can take that. So please concentrate on the words they are using. Must be, definitely, can be. So what it mean, then only you go for that. Let's take some numbers. So I am going to use prime numbers as well as composite numbers. Prime numbers, which numbers we can use? Prime numbers means 3, 5, 7, everything is correct, but the only even prime number is 2. So don't forget to use 2, because sometimes all the numbers gives the same kind of answer. The odd and even can change those things. So the only even number is 2, so you need to use 2 also. Then composite numbers. Composite numbers we can take 4, 6, then 8, 9. Here the different type of number is 9, because maximum composite numbers are even number, very few numbers are odd numbers. So at least we should check with 9, 15, these things also, right? Okay, let's start with the first equation. P plus C over P minus C can be even number. Just take any numbers. I'll take P is 2 and C is 4. So 2 plus 4, 2 minus 4. Here 6 and here 2 minus 2, I get negative 3. So negative 3 is an odd number. Don't look at the symbols, even negative or positive, that is not important. I want the number is even or odd. I got odd number, so that it is not right. Don't take like that, because they use can be. So check another combination. If all types of answers gives only odd number, means this is wrong. So check with any other number. Let's take different type of combination. I will take 3 from prime number and 9 from the composite number, plus 9 and 3 minus 9. So here 3 plus 9 is what? 12, and here I will get minus 6, right? Look at this, here we got minus 2. Yeah, this is even number, they says it is an even, so this is right. Yes, so take with some different combination numbers, okay? Right. Next, go for the next one, 2p plus c, right? 2 times p, as usual I take the first combination, plus c is 4. What I will get? 2 into 2 is 4, 4 plus 4 is 8. It is an even number, but they says it should be an odd number. Let's take the different combination, 2 into, I will take an odd number 3, plus here also an odd number 9, that is equal to what? 3 into 2 is 6, 9 plus 6 is 15. Look at this guys, I got an odd number. So this is also right, because it is can be. Any one number gives this answer, I can consider that, right? Let's move to the next one. P into C can be odd. See, this we know that even into even gives even number, even into odd number, 2 into 3 it gives even number, then odd number into odd number, 3 into 5 it gives an odd number, right? So let's pick one odd number, and here also an odd number, 3 into 9 is 27. So yes, this can be odd is also right. So our answer will be 1, 2 and 3, all the 3 are correct. So the only thing is, you should concentrate on the word can be or must be, what it was, right? Let's move to the next question. Right, for any choice of values of x, y and z, the 6-digit numbers of the form x, y, z is divisible by what? Already I had explained this question in previous video. Even though I just say only one thing, please listen. Whatever the number multiplies by 1001, you will get the same number again. If I take multiply this with x, y, z, I will get this x, y, z 2 times. That's the concept. So 1001 into whatever the number. If I take 594, my answer will be 594 and 594. This will be my answer. Okay, because 1001 is nothing but 7 into 11 into 13. Okay, so whatever the number is divisible by 2 times, definitely it will be a multiple of 1001. If it is multiple of 1001, that factors will be 7 into 11 into 13, 7, 11, 13 divisible. So the answer is option 3. I had detailed explained given in the previous video, you can check in that, right? Okay, next question. Look at this. A, B, C working independently can do a piece of work in 8, 16 and 12 days respectively. A alone work on Monday, B alone work on Tuesday, C alone works on Wednesday, A alone again works on Thursday, and so on. Consider the following statement. Okay, so everything is given. This question comes under time and work concept, alternate method. Okay, alternate days working. But if you don't know also, we should know one concept well, we can get the answer. Just I am going to explain this. Listen. First they talking about A, right? Okay, A, B and C. I am going to take A, B and C, right? A completed a job in 8 days and B in 16 days and C in 12 days. All these are days, right? Okay. I need to find out 1 day work. that is the efficiency or capacity. Without 1 day work, we will never get the answer. If I want to find out the 1 day work, I need to take LCM of these three numbers, 8, 16 and 12. LCM is what? 48. Right. Now, let's take 8 into what number gives 48? 6 8s are 48. 16 into 3, 12 into 4. If you add these numbers, you will get 13. Okay, keep this. Okay, this is individual efficiency. A can complete 6 chocolates in a day. So, he can complete 6 chocolates in a day. In 8 days, he can complete 48 chocolates. B can complete 3 chocolates in a day. If you gave 16 days, every day if he complete 3 chocolates, 48 will complete it. C can complete 4 chocolates in 1 day. In 1 day 4 chocolates means in 12 days he can complete 48. This is what the concept. Now, but they are not working together. They says that A alone works for Monday, B alone works for Tuesday, C alone works for Wednesday. So, in 3 days they can complete 13 chocolates, not in 1 day. This 13 chocolates was completed in 3 days. Okay, right. Out of this 48, first 3 days, right? Let's take first 3 days. They completed 13 chocolates. First day A, second day B, third day C. So, 13 chocolates was completed. Remaining is 35 chocolates are there. Next 3 days, again they will complete 13 chocolates, right? So, 22. Remaining is 22 chocolates are there. If I gave another 3 days, what happened? Again 13 chocolates was completed by these 3 people. So, 22, 13, 7, 8, 9. Now, the remainder is 9 chocolates. And now, I am not going to give work for 3 person. Look at this. Remaining is 9 chocolate. Now, let us take one by one. Next day, already 3 days, 3 days, 3 days. 9 days is over. 9 days is over. 10th day, A will come and A can able to complete 6 chocolates in 1 day. So, out of 9, 6 chocolates was completed by A in 1 day, right? Okay. So, 9 days will become 10 days. Now, what is the remaining? 3 chocolates are remaining. Now, B going to come and work. B can complete 3 chocolates in 1 day. So, this remaining 3 chocolates was completed by B in 1 day. So, the job was completed in 11 days. So, 3 days 13 chocolates will completed. Next 3 days again 13 chocolates was completed. Remaining 22 chocolates. Next 3 days again 13 chocolates will completed. So, 9 days was over and next this is less than 13. 9 chocolates only there. So, I am going to give work to A. A can able to complete only 6 chocolates in a day. So, out of 9, 6 chocolates was completed by A in 1 day. So, 10 days is over. Next 3 chocolates is remaining. This job was completed by the next day by B. B can complete, B's efficiency is 3. The chocolates also 3. So, B can complete the chocolates in the 11th day. This is the concept. Now, look at this. The work will be finished on Thursday. Look at this. Work was started Monday, right? From Monday, you need to take 11 days. Okay. So, Monday plus 11. Just count. You can get this Thursday. Yes, this is right. Okay. Or else 11 days, there is 1, 7 is there. What is the remaining? Remaining is 4. Remaining is 4 means Thursday. Monday is first day, Tuesday, Wednesday, Thursday, 4. Everything is right. Next, the work will be finished in 10 days. It is not finished in 10 days. It was finished in 11 days. So, this is wrong. So, only one first statement is correct in this question. This comes under time and work. So, this is the concept. Is it clear? Right. Let's move to the next question. So, this question is, it takes little bit more time to getting the answer in exam also. So, if you got this kind of question, maybe you can get the answer or you may not. So, do this kind of question at last. Most of the time students are thinking that which question I can skip. So you can skip this question, but we can get the answer. I will explain that. You can try this type of question at last. That is a kind advice for doing this problem. Okay, let take this. A box contains 14 black balls, 20 blue balls, 26 green balls, 28 yellow balls, 38 red balls and 54 white balls. Consider the following statements. Two statements are given. Okay, this is nothing, only the number of balls is given here. So you can't judge anything here. Let's see the statement. The smallest number n such that any n balls drawn from the box randomly must contain one full group of at least one color is 175. Here you need to, don't confuse with this question, because you need to understand that they are talking about one full group of at least one color is 175. You can check this word again and again. Okay. These kind of probability question, permutation combination question, at least at most questions, we always check with the worst case. Okay. So one full. Let take the statement first. Black ball, right? Okay, I will write here first. Black ball is 14. Black ball is 14, and then 20 blue balls. Blue is 20, and then 26 green balls. Green 26, then 28 yellow. Yellow 28, 38 red, 54 white. White 54. Okay, everything is given. Okay. The concept is they are talking about smallest number n such that the n balls drawn from the box randomly must contain one full group at least. I need one full group. One full group means if I take all the 14 balls, that is one full group. If I take all the 20 balls, that is one full group. If I take all the 26 green balls, that is one full group. And they are saying at least one. So you can take at least one means minimum one should be there, more than that. So worst case is what? At least one is how many? What is the probability of getting at least one? Then 2, 3, 4, that is no needed. One is enough for me. If more than one is also okay for me. That is worst case. First find out at least one. Then we go for the others. So if I take at least one, it is possible that 175 balls. Okay. I am not going to take any complete thing because they need at least one, right? So leave one balls in everything. Look at this. From the black ball, I am going to take only 13 balls. If I take complete 14 balls, means that is one full group. I am not going to take. I am going to take only 13. And from 20, I am going to take only 19. And 26, I am going to take only 25. From 28, I am going to take only 27. Here 37 and 53. Look at this, guys. There is no one full group here. If at least one full group is here, they will be satisfied. Okay, first count this. How much I got? Listen, 9 plus 3 is 12. 12 plus 5 is 17. 17 plus 7, 24. 24 plus 7, 31, 31 plus 3, 31 plus 3 is 34, right? And remainder 3. 3, 4, 5, 6, 7, 8, 9, 12, 12 plus 5, 17, 174. Look at this. Still now, I got 174 balls. If I add one ball with this, I will get 175, what they needed, right? So I can add that one ball, maybe from the black or from the blue or from green, because everyone I have left one in all the colors, right? If I add any one balls with this, that one, if I add one ball from black, so 13 plus 1 is 14. So what they needed, one complete group is came at least to one. Okay, this is the worst case. So this concept, what they are saying in this statement is right. It minimum I will get 174 plus 1, 175. This is right. Clear? And next thing, look at this. The smallest number m such that any m balls drawn from the box randomly must contain at least one ball of each color. Here we need to understand one thing. They need talking about one ball. Here they are talking about one full group. But in the second statement, the same concept repeated again, but they are talking about one ball of each color, at least one ball of each color, it gives 167. Okay, so see, if they are talking about one ball, let me leave any one from this. Again, I am going to take the worst case. You can leave black or blue or green or yellow, red or white, but I am going to leave the first one 14. Why I am leaving 14? I will explain that later. Look at this. Take 20 balls from blue, all the 26 from green, all the 28 from yellow, all the 38 from red, all the 54 from white. If you add all these numbers, I will get 166. Okay. If I add that one ball, they are talking about one ball. At least if I add that one ball with this, okay, the such randomly must contain at least one ball of each color is only one ball I should take from any one. That is possible for 167. Yes, if I take only one ball from black. So in these colors, black is only one. Black is only one. Other colors are n number of colors are there. So the question is, sir, why I left black? I can left blue also, right? Green also. Yes, you can left whatever the number, but there may be a chance of 167. See, if I leave 20 balls, okay, my number will be less than 166. Okay, it may be again it 150 something. If 150 something, let's take 155 plus 1, 156. I am not getting this value. If I subtract 26, I leave this 26 and add all other numbers. 10 balls, 155 or 154 only there. If I left 54 balls from this, okay, 54 balls means only 100 balls. 100 plus 1, I will never get this 167. If I want 167, I need to search the least number from this. Least number is black. That is why I left black and check with that. Any one values at least only they are asking. They doesn't says you should leave black or blue. I hope you guys understand this, right? You can check with the blue, green, any one gives this 167, their statement is correct. So only for black, if I leave that, it gives. Other numbers are ranges so far, so I am not going to check those numbers. If black gives the answer, that is the right answer. So this is also right. That is the concept. Clear? Okay. Let's move to the next question. So this comes under the reasoning topic, ranking and ordering. Anyway, right. So first, A is older than B, C and D are of the same age, E is the youngest person, F is younger than D, F is older than A. How many statements given above are required to determine the oldest person or persons? Maybe this statement looks odd, it something gives, right. So options are given. The options are started from 2, minimum 2. Okay. See, A is older than B. So from the first statement, A is older than B. Okay. From the first statement, can we say that who is the oldest one? No. Okay. If I take two statements, C and D are the same age. So C and D are same age. If you use both the statement also, I can't able to say who is the oldest person. Correct? Let's take 3. E is the youngest person. E is the youngest person. So the last youngest one is E. Everyone is more than E. Okay? Right. And next, F is younger than D. Next one is F is younger than D. Okay. Look at this. From these values, I can't able to join one with another one. I don't know C and D is before A or after B. I don't know. E is last, that is constant. Okay. D and F, there is no, D is here. So we can add here F. Okay. Yeah, I can add here F. E is the last person. Okay, still I don't know A and B, where should I write? Okay, so as of now I had written 4 values, still I am not getting the answer who is the oldest one. So here 2 is wrong, 3 is not, 4 is also not, so that I am not going to take 5, even though we can check. F is the older than A. F is older than A. Now F and A are connected, right? So F is older than A means my answer will be C, D, then F. F is older than A, so then A, then B, and the last person is C. Sometimes students ask me, sir, why should we need to take this E is the youngest? Without that also we can find. No. If they doesn't say E is the youngest, where should I write that E? Right? Maybe E is also the oldest person. So that also needed. All the 5 is needed for getting the answer. And one more clue is they clearly says that the oldest person or persons. That means they may be more than one. Yes, I got more than one. C and D both are same age. So both C and D is the oldest person. That is why they are using this word cleverly, right? Okay, so there is one more question based on blood relation, right? Yeah. Consider the following, include the questions and the statements. There are 5 members in a family. Question, what is the relation of E to B? Right, what is the relation of E to B? A and B are married couple. If I says that A and B are married couple, can you get the answer? Here they are not talking about E. Okay, next statement 2. D is the father of C. D and C is not given here, but they says D is the father of C, right? Okay, next, E is D's son. Where is E? E is not given here. D's son is E. So, son. E's son is, oh sorry, E is son, D's son. Right, everything is right. Okay, still now E and B. E is here, B is here, but I am not able to connect these two. Let's see the last statement. A and C are sisters. A and C are sisters. A is here, C is here, both are sisters means this diagram will be like this. A and B are couple, right? A and C are sisters. So he will be the male, a couple, sisters. You can write here, sisters. Okay. Next, from C, father is D. Right, he is the father, and E is son. So they are asking from E to B. So from B you need to check. Look at this. B's wife, wife's brother, right? So wife's brother or wife's sister, likewise the answer will be. So if I want to find out the answer, they are not asking the answer, but from this I need all the 4 statements. So look at the options. Statement 1, 2, 3 are sufficient. Statement 1, 3 and 4 are sufficient. All 4 statements together sufficient to answer the question. All 4 statements are not sufficient. No, I can pick option C because I can get the answer after this, and also I get all the genders also. Definitely I can able to answer for this question. Is it clear? Right. So there are so many data sufficiency questions are there, and the next part, the part 2 will be the next class. I am going to explain the remaining questions. So practice well for concentrate more on data sufficiency question, because they are not needed the answer, they going to check how you understand the concepts well. So all the very best guys, thank you.